Hi everybody, today we're going to look at induction and we're also going to create polygons. So go to GeoGebra and then algebra and let's create the most basic polygon. We want to show that the sum of the interior angle of any n-gon, where n denotes how many vertices you have, will be n minus 2 times 180 degrees. So let's go ahead and create the most basic n-gon, which would be a 3-gon or a triangle. So you will just go to the polygon icon and then you will create your triangle. And we can actually go ahead and measure the angle. You always want to measure clockwise if you want to find the interior angles. So you click on C, B, A, and that will provide you with a measure of angle B. And then you click on B, A, C, and that will give you the measure of the angle A. Okay, and let's, well, this lesson also covers how interactive and dynamic GeoGebra is. So let's go ahead and define my sum to be S, and S now will be defined in terms of this angle alpha, beta, and gamma that we measured over there. So let's go ahead and say it's equal to alpha plus beta plus gamma, and that's going to be the sum. And you can see that it's going to be equal to 180 degrees. Actually, we proved that it's equal to 180 degrees in our previous project. So we can write here, and you will go to text, and then that should bring up a box. And let's go ahead and write that the sum of the interior angles of a 3-gon is then, according to our formula, it's going to be n minus 2, which is 3 minus 2 times 180 degrees, which is just equal to 180 degrees. So the formula works for the base case. Let's go to the next case. So we're going to create another polygon, and now it's going to be a 4-gon. So that's going to be my polygon. And I have created a few angles again. So let's go ahead and measure those angles as before. So we're going to measure angle E by clicking on FED. We're going to measure angle D by clicking on angle EDG. We're going to measure angle G by clicking on DGF. And it's important to click clockwise if you want to measure the interior angle. And let's go ahead and maybe let's get rid of, I'm going to get rid of my my 3-gon for a second, so that I have some room for my 4-gon. And so you can see, well, before I delete it, you can see that if you change the angles here, your angles will change over here. Now alpha is 54 degrees, but the sum would still be the same. The sum is still going to be 180 because it doesn't matter how the angles change, your sum would still add up to 180. Okay, so I'm going to get rid of that triangle over there. And let's take a look at the 4-gon. So let's go ahead and define T to be the angle delta plus epsilon plus gamma that's psi plus eta. Oh, that's not psi. That is, there we go. Okay, so this is how I define t to be now. So it's going to be this angle plus that angle plus that angle plus that angle. So I want to see what's the sum of the interior angles of a four-gon, and you can see that it will be 360 degrees. Now, if you really think about this, you can imagine that you can break this four-gon into two triangles. I have the formal proof in the notes. I just wanted to give you an intuitive idea of what's really going on, how you prove it by mathematical induction. So with mathematical induction, we are assuming that it's true for k, and we need to prove that it's true for the case k plus 1. So we assume that the sum of the interior angles of a triangle is 180. So using that, we know that the sum of the interior angles of a four-gon will be 180 plus 180. And that's what the proof is about. So that's going to be 180 plus 180, which is 360. And the same thing is true for a pentagon. If we would graph a pentagon has 5 vertices, then you can see you can either divide this pentagon into a triangle plus another triangle. So the sum of the interior angles will be 180 plus 180 plus 180. So that's one way of doing it. So 180 times 3 gives you 540 degrees. Or you could divide it into, by mathematical induction, that would be true. Or you could divide it, your pentagon. Oh, let's just create a new one. Let's say we have this pentagon. It looks like this. We could divide it into a triangle and a, I'm sorry, I should have not picked a line there. I should have picked line segment. Let me go back one. Let's go ahead and pick line segment instead. So I could have broken it up into a triangle. The sum of the interior angles of a triangle is 180, and we've just proven that the sum of the interior angles of a four-gon is equal to 360. So that will also give you 360 plus 180, which would give you 540. And that's in line with my general formula here. So the sum of the interior angles of a pentagon is equal to n, which is going to be 5 minus 2, which is 3 times 180. And you can see it very clearly here. Okay, thank you very much. So I just wanted to give an intuitive idea of what's going on with this proof, but I've proven it formally in the notes, and then I have an exercise for you on diagonals that I want you to prove in terms of mathematical induction.